What good is a flint if it is not struck properly to produce light? Similarly, the human mind is full of latent energy, ready to burst into action, provided it's given the right kind of stimulus, the kind of stimulus we are trying to provide to you with our weekly inter-school science quiz, Quest. Let me begin by welcoming the Director of National Council Science Museums, Dr. Jayanta Sthanapathy. Let's have a big hand. Hello, sir. Hello. The participants today, on my right, the 𝐺𝐶 team. You are?
I'm Shohini Das from Calcutta Girls High School.
I'm Ipshita Mishra from Calcutta Girls High School.
I'm Chandrima Chakraborty from Calcutta Girls High School.
Welcome to our show. Let's have a warm round of applause for them. On my left, the C.V. Raman team, and you are?
My name is Bhaskar De. I'm from Vivekananda Mission School.
I am Shomo Rai from Vivekananda Mission School.
I am Arindam Sharnal from Vivekananda Mission School.
7 questions in all. The first 4 are direct questions, 2 each for both the teams. 20 points if you get them on direct and 10 on passes. You have approximately 15 seconds to answer your direct questions. If neither team can answer the questions, they go out into the audience. The last 3 questions, as usual, are on the buzzer. So let's not waste any further time and get on to the very first question, which is for the 𝐺𝐶 team seated on my right. Your question, 𝐺𝐶 team.
This is a spring-like object. Okay. If I pull one end of the spring-like object in same plane, it oscillates. Okay. Now, I am placing it on the top of a staircase. One end of the spring is fixed, or I am holding it here and pulling the other end here. When I am placing this object on a staircase, it moves downwards, just like a worm. Why this is happening?
When you're placing it on a plane, what's happening is you have the 2 rings,
Okay.
the base 2 rings, and then as because it's on the same plane,
Yeah.
the force of gravity will be the same on both the sides, and so it's going to be oscillating from one side to the other, because when this side becomes more, it comes back to this side,
Okay.
and then it keeps on oscillating.
Right.
And in case of a staircase, you're having it on the upper case, for example,
On the
and
top,
then
say,
on the
yeah.
top one, and then after that, it's like when you put it down to the next one, it comes down like half. Let's say a greater part of the number of rings comes to the second case because of gravity, and at the same time the
Okay,
attraction of the
right,
spring.
right.
And then while it's in motion, the spring moves up and it's attracted by gravity, and so it moves down to the other case because of gravity. Like it's already in motion.
In motion.
So
Yes.
it's like during inertia of motion,
Right.
it moves down. So
Right, that's the correct answer. But I have to explain it for you. When the spring is on the same plane, both the ends are at same potential energy. In this case, when it is on the top of the staircase, this has highest potential energy. I am pulling this to a lower energy state, and because it is a spring, the mass is pulled down to this stair. But while in motion, it has inertia. Because of that inertia, it tends to go to the next step. And similarly, because of gravitation, it is pulled down and down and down. It goes like that. So they get full marks.
Let's have a big round of applause. Ipshita from Calcutta Girls School on the 𝐺𝐶 team with a brilliant answer, picking up 20 points. The next question is for the boys from the C.V. Raman team. $20 points to the 𝐺𝐶 team. C.V. Raman team yet to open their account. The very first question for them.
This is a single pen balance. If I press it, it shows weight, right? The beaker has water in it, and I am putting on the pen. It shows 250. That means the weight of the water and beaker is 250 grams. I am putting another weight of 200 grams on the pen. It shows 450. Now the question, if I dip this weight in the liquid so that it is in a immersed condition, okay, what will be the reading of the balance?
The reading of the balance will be more than 250, but it will be much less than that 450 mark, because because it is due to the upthrust, there will be a loss in weight.
Yes.
Because of the upthrust there will be a loss in weight, and that loss in weight will be equal to the force exerted by the
Water displaced,
water
water
displaced, and so the beaker will go the weight will increase, but it will not increase as much as
the actual weight
As it is when it is kept here.
Yes.
Now if I dip the weight completely in the beaker, what will happen?
The weight will be 450.
What will be 450, right? Very good. I am dipping it not fully, so it is something
around 300.
more than 250
Yes.
and less than 450, as you said. This is absolutely right. And if I release this, this shows 450 grams. Very good answer. So you get 4 marks.
Well done, Bhaskar and Shomo, picking up 20 points for your team, answering in tandem. The next question is for the JC Bose team. £20 apiece. Next question is for the JC Bose team.
In this beaker, I have kept sodium chloride solution, and I have added few drops of phenolphthalein in the solution. Through these two electrodes, I am passing direct current, and you see there is a change in color.
Basic now.
Can you see a change in color? So from colorless, it's becoming pink. What is the reason?
Sodium chloride solution has sodium chloride and obviously water. So
Okay.
In this case, as you're passing the electric current, it's going to be it's an electrolytic dissociation,
Right.
and so sodium and chlorine is being dissociated. At the
Yeah.
same time, water is being dissociated.
Into hydrogen and hydroxyl ions. So the
Right.
hydroxyl ions and the sodium ions react together to form
Sodium
sodium
NaOH,
hydroxide.
which is alkaline, and therefore the
Alkaline.
phenolphthalein changes color to pink.
Pink.
Since
That's all. What happens to chlorine?
It's forming hydrochloric
Chloride
acid.
ion.
hydrochloric.
Yeah. It's forming
Forming
hydrochloric
hydrochloric
acid.
acid.
No.
Okay, that's not the
No, no, no.
question anyway. And what happens to this hydrogen ion?
Hydrogen and fluoride.
That would form
It's being liberated.
hydrogen
And that's
gas.
forming hydrogen gas and it's being
So
liberated.
you have given the correct answer to my question, that why it is becoming pink. That's right. So they get full marks.
Forgetting first.
Another 20 points, all three girls answering together. Dr. Sanapati?
I have to add, yes.
Yes, I think you
Sodium
must.
chloride is neutral, and because of electrolysis, it breaks into sodium ion and chloride ion. And as you have said, the water is also breaks into hydrogen ion and hydroxyl ion. So OH and Na, they combine together to form sodium hydroxide, which is a strong alkali, and in presence of phenolphthalein, which is an indicator, it makes pink color. That's the correct answer, which you have already given.
Dr. Sanapati, I have a question for you.
Yes, please.
What if you stop passing the current through the water now? Will it revert back to its...
Oh, yes, yes.
It will.
Right.
Can you explain why that happens?
In that case, again it will transform into sodium chloride, and water, because the entire hydrogen ions are not transformed into hydrogen gas.
All right.
Some are already there. So we get the reversible reaction.
So 40 points to the J.C. Bose team. The next question is for the C.V. Raman team. Let's see what they do with their direct question. Boys from Vivekananda Mission School, you are on 20 points. This is your chance to catch up with the girls. Let's see what do you do.
In these two test tubes, I have organic solvents. One of these is benzene and the other one is chloroform. I do not know which one is what. And I have added a dye called carmine. Carmine is added to both of these, but that is not making a true solution. Okay, this is not mixing up. Now I am adding water in both the test tubes. You can see the test tube in my left hand has the red solution on top, and this is a perfect solution. But in the other case, the solution is at the bottom. You have to tell me why this has been dissolved, the carmine has been dissolved, where it has been dissolved, and what are these two colorless liquids.
On the beaker in the left hand side,
Yes.
benzene is present, and the colorless liquid is water. Benzene is lighter than water, so it floats in it, and the red carmine solution. And on the left hand side, it is chloroform. And
Chloroform at the bottom or at the top?
chloroform at the bottom.
At the bottom. So you mean to say the carmine has been dissolved into chloroform, and in this case that has been dissolved in benzene.
Benzene.
No, water, because water is, no, what did you say?
Tell me very clearly.
In the beaker in the left hand side, it's benzene. Benzene is lighter than water, and
So benzene on top,
benzene on top.
and at the bottom
It's water.
water, and in this case
Uh,
I think there is a residue.
I think the water is on the bottom and the chloroform is on the top, and the carmine has dissolved in the water.
in both the cases carmine has been dissolved in water.
No, in the left hand test tube, it has been dissolved in
Benzene.
Benzene.
Oh, I am very sorry, it's absolutely wrong. Now it's your chance.
Just try. In both the cases, it's lower on water. That's one thing. Go. See.
Girls, are you trying?
In both the cases, the carmine has been dissolved in water.
Okay.
In case of the one where the carmine is down and the colorless liquid is up, that is chloroform.
Here
It's chloroform.
in my right hand,
It's chloroform.
this is chloroform on top,
Yeah, and that is
and in my left
benzene.
hand,
That's benzene.
benzene at
Yeah.
the top.
Benzene at the bottom and water dissolved with carmine at top.
Okay, anyone from the audience?
Yes, you'd like to come up? Please come. What's your name?
Hansen was from AGCS.
Do you have an answer?
Yes. In this both case, the pigment has been dissolved in water.
Very good.
And in the first, in your right hand,
Yes.
benzene is lighter than water, so it floats.
Okay.
And in your left hand, chloroform is denser than water, so it sinks. So it's
That's the right answer.
Wonderful answer, Hanson. Here's a small memento for you from Quest. Thank you. Dr. Sanapati, would you like to add to that?
No, I have already said.
Okay, so no points to either team there. Scores remain exactly where they were. The J.C. Bose team is on 40 points, and the boys of C.V. Raman team still on 20. Welcome back to Quest, the inter-school science quiz brought to you by the National Council of Science Museums and Doordarshan Kendra, Kolkata. At this stage of the contest, the girls of J.C. Bose's team, that's the girls from Calcutta Girls School, are on a handsome lead. They've got 40 points. On my left, the boys from Vivekananda Mission School, that is the C.V. Raman team, they are on 20 points. The next 3 questions, which are the last 3 questions of today's quiz, are on the buzzer. As always, plus 20 if you get it right, minus 10 if you do not get it right. Questions do not pass to the other team, they pass straight into the audience. And teams, do remember one thing, be ready with an answer when you hit that buzzer.
This is a normal gas lighter. Nothing special in this lighter. But if I bring below this net, the flame gets extinguished. Again. When I bring it out, it glows. Extinguished. Now, the experiment. The flame is extinguished. The flame appears over the net. But below the net, that means the gap between the burner there is no flame between the gas lighter and the net, but the flame is there above the net. What is the reason?
For a substance to burn, it must reach its ignition point. And when the
What is ignition point?
the temperature at which it will burn.
A temperature. Okay.
When the gas lighter is held below it,
Yes.
the where that gauge, it conducts away heat rapidly. So the air above it cannot catch the flame. So
Yes.
we are not seeing the flame on the upper side of the gauge. And when it is held on the upper side of
below the gauge.
Below the gauge.
But the gas is passing.
Gas is passing.
Gas
right.
is passing.
Absolutely
So
right.
when we are igniting it above the flame, it is catching fire.
It is catching fire. Very good answer. That's the right answer.
Well done, boys.
Yeah.
You pick up 20 points for your team and draw level, 40 points apiece. Dr. Sanapati, would you like to add to that?
They have said the right thing. Again, I am saying.
I have a question for you, Dr.
Yes.
Sanapati. Theoretically speaking, as he very well explained, the flame did not reach its ignition point,
The temperature.
the temperature.
Yes.
Therefore, it did not ignite.
Right.
Now, let's understand that the entire heat is being dissipated into the net.
Yes.
So, if that net reaches that right temperature, will it ignite?
Oh, yes, it will ignite.
It will ignite.
It will ignite.
All right.
Yes.
Thank you.
And if the net is heated,
Yes,
then it will ignite.
it will ignite. in
This trick will not take place.
All right. Okay. Next question is again on the buzzer. $40 points to each team, and we are into the second last question of today's quiz.
In my left hand, I have a solution of cobalt chloride. I'm telling you that this is hexaquo cobalt chloride. Okay? And it has very light pink color. I'm adding concentrated hydrochloric acid to this solution. Agree. We get a light green solution. What is the compound?
Hurry up, teams. You have not very much time to go. I'm afraid the time's up. Neither team going for the buzzer. Anyone in the audience? No one in the audience. Teams don't have a clue either? I guess, Dr. Thanapathy, this is the quiz master's question.
Okay. This is cobalt tetrachlorocobaltate 2. Very difficult?
Yeah.
Okay.
I don't know how you pronounce that tongue twister, Dr.
Oh,
Thanapathy.
yes.
Anyway, neither team scoring anything there as we go in to what is going to be a fitting finale. Both teams tied on the same score. Anything can happen, and we'll come back to you with the very last question in today's quiz. Quest. Welcome back. You're watching Quest, the inter-school science quiz brought to you weekly by Doordarshan Kendra Kolkata and the National Council of Science Museums. We are into what is going to be the last question of today's quiz. Anything can happen, both teams on the same score. And Dr. Thanapathy has got the next one under wraps. Here we go.
In this test tube, I have concentrated sulfuric acid. And I am going to pour this in a beaker which contains sugar. What will happen?
When you add the concentrated sulfuric acid, the sugar will turn black because that concentrated sulfuric acid is a dehydrating agent, and sugar being a carbohydrate, the concentrated sulfuric acid will absorb the water part from the carbohydrate, and the carbon will remain, and so it's going to form a black.
Very good. That's the correct answer. That's right.
Let's have a big round of applause for them. Dr. Thanapathy?
What they have said is correct. You know, the color has started changing. This is cane sugar, which is a carbohydrate. And concentrated sulfuric acid is a dehydrating agent. So if I add sulfuric acid to that, the hydrated part, that means the water is taken away by sulfuric acid. So carbon remains, and carbon is black. So we get black color.
If to charcoal we add water, we hydrate it, will it turn into sugar?
Oh, no, this is not reversible.
It's not reversible. Okay. Coming through as winners then in the tiebreaker, picking up 20 points, finishing with a total score of 60 points are the girls from Calcutta Girls' Schools, the JC Bose team. Let's have a big round of applause for them. Well done, girls. Thank you for coming on to our show. Vivekananda Mission School, that's CV Raman team. Don't look so disappointed. Thank you for coming on our show. This brings us to the end of this week's edition of Quest. Please write back with your comments and your queries to Quest, care of Doordarshan Kendra Kolkata, 18/3, Uday Shankar Saroni, Golf Green, Kolkata 95. We'll be back again next week at the very same time. Till then, it's goodbye from all of us.